Example 19 on page 513. Use the laws of exponents to simplify this expression. Alright, now, you know that you cannot combine these two terms, these two factors, because this is A, the base is A, and this is the base is B. So A and B's are different. That means you cannot combine these two. Okay. Normally, if you have A here, you can combine by adding the two exponents. But because you have different base, A and B, you cannot use the law of exponents that combine these two variables by adding the exponents. Okay. So leave as is, and you cannot combine. Now we have the 1/2 outside as the exponents of both these variables. So we're going to use this laws of exponent for this example 19. Okay, for this case. Now they look a little bit different, but they're very similar. Okay. So let me work on the side. What if you have the case that you have two different base, like this case, okay? So suppose you have two different base, like this case AB, one have exponent n, m, one has exponent k, and you have n outside. To solve this, you can be writing this as distribute this exponent n to each exponent. So n times n, okay, which is very similar to this, okay? M times n, because we have another variable. So make sure you multiply b, okay? And then multiply the exponents of this n to the exponent of b, which is k times n, okay? So I'm going to use this for this. We have two different base, okay? But again, this is from this, okay? The only thing different is that this has one base, which is A. This has two base, which are A and B. So, given A -1 divided by 3 times B 2 divided by 5, everything raised to 1 divided by 2. Alright, we're going to distribute the exponents here, the outer exponent, to each exponent of each base. So A -1 divided by 3 times 1/2, okay, because I distribute this to the exponent of A, which is 1 divided by 2, times this second base here, which is B, and then you distribute 1/2 to the exponent of B, so you have 2 divided by 5 times 1 divided by 2, okay? So I just split these two base here and distribute this outer exponent 1/2 to each base, to each exponent of each base, okay? And then simplify as much as possible. Alright, so you see that this is the product of -1 divided by 3 times 1/2. You can simplify this to -1 times 1 is -1 divided by 3 times 2 is 6. Okay? So we can rewrite this as A, replacing the products of -1/3 times 1/2 with this, which is -1 divided by 6. Okay? Well, this B right here, you can simplify this to, so you have the product 2 divided by 5 times 1 divided by 2, and you can simplify this to 2 times 1 is 2. Now, actually, you can simplify actually. For this case, because you don't have any common factor between this and this, this and this, or this and this, this and this. For this, you actually have 2 and 2's here. So you know that you can simplify this 2 and this 2. So 2 divided by 2 is 1. And this you cannot simplify 5 and 1, so just leave it as 5 here. Time. So 2 divided by 2 is 1. this 2 divided by 2 is 1. Okay, if I simplify D2 to 1 and 1, so again, 1 and 5 cannot simplify, so leave as is. So you don't have any more common factor between the two fractions. You can simplify by by multiplying numerator together. 1 times 1 is 1. 5 times 1 is 5. So the products of 2 over 5 times 1/2 is 1 over 5. So you will replace this product, 2 divided by 5 times 1/2, is here equal to 1 divided by 5. Okay? Again, D2s are different base, they're different, so you cannot combine them. And look like this is the simplified form, and you cannot simplify any further. So A raised to negative 1 divided by 6, and then everything times B raised to 1 divided by 5 is the answer for simplifying this expression.